This is lesson 9-2 in Algebra 2, series and summation notation. There's a lot of S's in this lesson, so we'll see if I get tongue-tied. We are going to evaluate the sum of a series expressed in sigma notation. See all those S's. Okay. So first of all, a series, what a series is it's just the sum of a sequence. Lots of S's. Series is a sum of a sequence. So a sequence is a list of numbers. A series is when you add up the list of numbers. So that's the only difference there. The last lesson we learned about sequences. Now we're going to add them all up. A partial sum is indicated by the notation capital S sub n. And that would be the sum of a specific number of terms. So if I had like S sub 5, that would be the sum of the first 5 terms. So if it was 1 plus 2 plus 3 plus 4 plus 5, then I could add that up and my answer would just be a number that is the sum. Summation notation, we use this Greek letter called sigma. When you draw it, it's just like a capital E thing. If you've ever used Microsoft Excel, you probably have seen that symbol there. They use it where they have the formulas and notation, and the most common formula used in Excel document is to add up all the columns. So it's the adding them all up symbol. The way it works is you have the sigma there, and then down here at the bottom you have your starting value, which is 1, and your ending is 5. So this means I'm going to start with term 1 and I'm going to end at term 5. My formula is here, and basically you plug in a 1, and then you plug in a 2, plug in a 3, plug in a 4, and you stop, and you plug in a 5, and then you stop. Because so it starts on the bottom, stops on the top, and you do them in here, and then you add up all those terms. And so I will show you some examples of how that works. But first, we're going to try to write it in summation notation. So first of all, you got to figure out what the pattern is, what rule is going on. So this is a sequence that we're going to add up. So if it was just 4, 8, 12, 16, 20, what pattern is happening here? And that is just adding 4 every time, right? Plus 4, plus 4, plus 4. So we need to write the kth term. It's basically the last lesson when we did a sub n equals. If I wanted the explicit form for this, let's see, I have my first term plus my common difference is I'm going up 4 and minus 1 times, right? Or in this case, I could just do 4 times 1, 4 times 2, 4 times 3. So it would also do another way to write this would be 4n. And if you distribute this out, by the way, and multiply this out, you get 4n minus 4 and plus 4. So that does equal 4n. So a simpler version. Either one of these would be correct. Anyway, so once you do that, you just write it with a k instead of an n. And it really doesn't matter what letters. Some formulas, some books use k, some books use n, because this is an n. Some use I, whatever number you want. And then we're just going to put that with the sigma. So we want the first 5 terms, 1, 2, 3, 4, 5. So we're going to start at k equals 1 and go to 5. And our formula was 4k. So when I plug in a 1, I get 4. When I plug in a 2, I get 8, 3, 4, and 5, I get 20. And then all I would do is add all those up. But all it said was to write it in notation for the first 5 terms. So that is the answer that they're looking for. This equals that, which equals a number when you actually add them up. All right, let's try another one. This one, negative 1, 1/4, 1/9, 1/16. And notice the signs are alternating, negative, positive, negative, positive. So we'll deal with that when we write our sequence as well. I really like n better, so it can be n or k or whatever. So what is the pattern that you see here? Well, these all have a 1 on the top. And then what's on the bottom? This is my first. Sometimes it helps me to write out what term number I'm looking at. So this is a 1, my first term, second term, third term. How is my number down here related to the term number? So 2, 3, 4, 5, 6. Do you see that relationship there? The bottom of the fraction is the term number squared. So I could put n squared here. And that would get me the 4, 9, 16, 25, 36. Now I have this negative. So what happens with negatives, if it's alternating, what we can do with negative is take negative 1 to whatever power we want. So since this is a -1 term, if I raised it to the nth power, if I did -1 to the first power, I would get negative. If I do -1 to the second power, I would get positive. So that works out. If your first term isn't negative, then you can just put like a +1 on here, and then that would make it even, and so your first term would be positive. So if you want to alternate signs, you just do -1 to the n or to the n +1 or -1. It really doesn't matter. You're just making odd or even to make sure the first term works out. All right, so that's my nth rule. I'm just going to put a k in it, and I actually like to have the -1 first, and I don't have to, I could just write it like this, k squared. Or I could write it like this. There's lots of ways to write this. Times 1 over n squared. Okay, that's a k. That's a k now. K squared. Anyway, now let's turn it into summation notation. So this time we're doing the first 6 terms, starting with a 1. So k equals 1 to 6. And all I have to do is put my formula there. Your choice which one you do. K squared. Just make sure you whatever letter you put down here, you have to use in your formula. So if you want to use n, you can. Just make sure it's down there as well. And that is the end of that one. Just this is a reminder. If the first term is negative, you're going to do -1 to the k. If the first term is positive, you just do -1 to the k plus 1. That way, when you plug in a 1 for the first term, you'll get an even and a positive answer. All right, here's another one. This one's very similar to the last one, so I would recommend pausing the video and seeing if you can come up with the sigma notation for the first 5 terms. All right, if you tried that out, we're going to take a look. So all of these have a 2 on top, and all of the bottom are, well, they're not 1 squared, right? This is the first term, second term, third term, fourth term, fifth term, but they don't line up this time. So there's a couple different ways to do this. One is to adjust. So if we do 2 over, if I wanted this to be my second term, I could do n plus 1 squared. Because n plus 1 would be 2 now squared, and this would be 3 squared, and this would be 4 squared. So this is one way to do it. So if I was doing the first 5 terms from 1 to 5, oh, this is not the answer to this problem. The summation from 1 to 5 of 1 over k plus 1, 2 over squared. They really messed up on the answers on this one. Okay, so you may have noticed, it's very similar to the last problem. One thing you need to know about sigma notation is it doesn't have to start at 1. If I wanted to, instead, I could call this the second term, third term, fourth term, fifth term, and sixth term, and I could add up starting from 2 and ending to 6, and my formula would be just a little bit simpler because first thing I would plug in would be a 2, and that would work out. And then I would go to 3, 4, 5, and 6 and stop. So either of these answers are correct. This one just starts at 1, and we adjusted it inside here, and this one starts at 2. So just so you know, it doesn't have to start at 1. One thing to note, though, is like when you start from 1 to 5, there are 5 terms, right? When you start from 6 to 2, there are 5 terms. So 6 minus 2 is 4, but because you also have the term that you started with, which is term number 2, you actually have 5 terms. All right, let's try another one. This one is alternating. Again, you can pause the video if you want to try this out. This is my first term, second term, third term, fourth term, fifth term. See if you can find that pattern. Not sure I'm going to trust these little boxes today. Oh, that looks good. Okay, so the pattern is it's alternating, negative, positive. So I've got my -1 to the k to make it alternate. And then this is just times 2, times 2, times 2, times 2, times 2 for my formula. In sigma notation, there we go. This was the answer on the previous slide. From 1 to 6, -1 to the k times 2k. So there's my sigma notation. All right, that's enough practice that way. Let's see about going the other way. So if they give it to me in sigma notation, they want you to expand and evaluate. So there are 2 steps. When you write these out, I do not want just the answer. I want the expansion and the evaluate. So make sure you show what you get. First of all, we're going to plug in a 2. So 1 over 3 squared, and that's fine. You don't have to write what that equals. Plug in a 3, plug in a 4, and plug in a 5, and that's where you stop, and you add, and then you answer. Okay, so this is where you would definitely be able to use your calculator. And if you didn't use your calculator, you would have to get common denominators here to add them all up. And the answer is 40 over 243. So just type that in and then hit math, enter, enter on your calculator to turn it back into a fraction. Here's another one to try. So this is a little bit easier. You can go ahead and pause the video and try it if you'd like. Expand, so write out all the terms and then add them all up. Pause the video and try that out. All right, so the answer, when we expand it, we're plugging in a 1 and then a 2 and then a 3 and a 4. So we get these terms. So this is what you should have for your expand section. And then when you add those up, you get 31. Answer's 31. So technically, you could just say 31, but the directions say expand and evaluate. So make sure you give me both of these lines here. Here's one more. Pause the video, see if you can get it right. And we're back. Let's see what they got for an answer. The expansion is in all of these negatives. When you add them up, you get negative 155. All right, we're going to switch gears a little bit here. What is the sum of all the integers from 1 to 100? It's a race. See who can add them up for the fastest. All right, well, I'll tell you there's a shortcut. So instead of typing in your calculator, 1 plus 2 plus 3 plus, oh goodness, I can't even write it right, plus 5 plus 6 plus 7, and so forth, all the way up. I'll go to like 97, 98, 99, 100. There's definitely a shortcut formula that can help us out. And so I'll just explain kind of where this one comes from. And it goes like this. Since I know I have 100 terms, I'm going to put that one down. I have 100 terms. I want to find the sum of the first 100 terms of this sequence. And this is how it goes. If you take the first plus the last, that's 101, right? What if I go in 1? 99 plus 2, still 101. 3 plus 98, still 101. So the first plus the last is 101. And then how many of those am I going to have? I have 100 terms here, but I just paired them all up. So I'm going to multiply that by 50. So the answer to this question is 5,050. The formula for this question is I take the first plus last and multiply that by the number of terms divided by 2. So S and the sum, it has to be an arithmetic sequence or an adding up sequence in order for this to work. And we're going to talk a little bit more about this formula as we go on. But I just wanted to show you, yes, you can type all of those numbers in your calculator, or you can learn the little shortcut. By the way, a lot of people mess up some button somewhere along the line, so it's much more efficient to have a formula. So these are some of the formulas that are just some special cases that can help us out, and they're on your formula sheet at the bottom of the page. So you can follow along there on the formula sheet as well as in your notes. So the first one here is if you have a same number and you're adding it up over and over and over again, and that's your sequence. So this sequence is 3, 3, 3, 3, 3, and we want to add them up. Well, that's just repeated addition, which we learned is called multiplication. So all you have to do is 3 times 5 and you get the sum, right? Just so you know, this is the summation notation. When you plug in a 1, you get 3. When you plug in a 2, you get 3. There's no variable here. So when the first term is 3 and the second term is 3, and so forth. So just so that notation doesn't confuse you, that's what's going on. There's no variable. So it's just constantly 3. And there are 5 terms from 1 to 5. Means I have 5 terms. So you just multiply it. So anytime you have a constant in this spot right here, you just take the constant times however many terms there are. If it starts at a different number, so like from 4 to 10 of, let's just do 5. What would that be? Well, it would be 5 times How many terms are there? If I go from 4 to 10, well, the answer is 7. You might have wanted to say 6 because 10 minus 4 is 6, but you also have to keep in mind that we started with that fourth term. So if you go 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7 terms. Okay, so the answer to this problem is 35, but just keep in mind that you can't just subtract these. You have to subtract them and add 1. You always add 1 because you have to count the first and the last term. A linear series, like the numbers from 1 through 100, like we just did. This is just their example. So you can add the first plus the last, which is 11, and so on. And I would have half as many of those, which is 5. So the formula for that is what we just talked about. Well, it's a lot like what we just talked about. You can just take the number of terms and then add 1 because it's like adding the first to the last. So if these are 1, 2, 3, 4, 5 up to some value, it has to start with 1 and go up by 1, then you can just do the number of terms times n plus 1 over 2. It's basically what I just showed you with the first plus the last. Similarly, you can do this for a quadratic series. So if you're adding, what's 1 squared? What's 2 squared? What's 3 squared? What's 4 squared? What's 5 squared? If you have a quadratic, see these are the perfect squares, you can find the sum of the first n quadratics using this formula here. I'm not going to go into where that all came from, but you can kind of see the n and n plus 1 is there, and then there's another part to find the other. Anyway, shortcut there. So make sure you have these 3 formulas. They're at the bottom of the formula page, or they are in your notes. You might have to come back to that one. And this is just a note about that 10 minus 5. This has 6 terms because 10 minus 5 is 5 plus the 1 more. So don't forget to add that 1 when you're trying to figure out how many terms there are. So let's evaluate this constant series. Method 1 is to use the formula. The formula says you just take the constant times how many terms there are. 10 minus 4 is 6 plus 1 is 7. 6 times 7 is, 42. There we go. If I wanted to expand it, I would have 6 is my 4th, 5th, 6th, 7th, 8th, 9th, 10th term. 4, 5, 6, 7. And so then when you add all those up, you get 42. All right, this one is a linear series. So K, because I plug in a 1 and then I plug in a 2 and then I plug in a 3, the expansion is 1, 2, 3, 4, all the way up to 8. I'm taking a little bit of a shortcut there. You could add all those up, or we can use our little formula, which said this. So we're going to take 8, because there are 8 terms. 8 minus 1 is 7 plus 1, times 8 plus 1 over 2. 4 times 9 is 36, and I could also add these up. All right, here is a quadratic one. So we're going to need that formula, which is on this other slide. So I'm going to check it real quick. 2n plus 1 over 6 goes here. All over 6. Okay, so now because this is quadratic and these have to start at 1 in order to use these shortcut formulas, otherwise you would have to expand them. So using the summation formula, we would plug in a 12. 12 plus 1 is 13. 2 times 12 is 24 plus 1 is 25, all divided by 6, and whatever you get with that is the answer. Which is 650. The other thing, you can do summations on your calculator. There is a button for that. So we'll go over that here in a moment. Let's see if I can. We have one more problem to just talk about real quick first. So Sam is laying out patio stones in a triangular pattern. The first row has 2 stones. I'm just gonna make circles because it's easier. First row has 2 stones. Second row has 4 stones. 1, 2, 3, 4, and the next one has 1, 2, 3, 4, 5, 6, and eventually this is gonna make a triangle. So we have 2 we're adding 2 additional stones each one. So this is my pattern, and I want to know when he will, or how many complete rows can he make out of 244 stones. So I could keep adding these up until I got to 144. But I also could kind of use my formulas. So I'm adding up, let's see, row 1, 2, 3, 4. Let's make a formula first. My formula would be just 2k, right? The sum from 1 to what of 2k? Well, when I sum up, you can actually take this 2 out. Let's look at the next page and see where we're going with this. So yeah, they just guessed. They just put a 10 in and guess. I would probably like set it equal to 144 and solve it, but that's okay. So basically, for my little problem that I've got here, I would guess this number until I found it to work. And now I'm going to show you how to do that on the calculator. Okay, so I'm going to show you how to use the calculator now. And there's 2 different things, and some of the calculators are a little bit different. So try to make some notes here about what to do. First of all, if we want, let's just make up an easy one to do here. It's k equals 1 to 5 of 2k. Let's find the sum of this sequence, okay? So we know it would be 2 plus 4 plus 6 plus 8. So it's basically the sequence we were looking at a minute ago. So on your calculator, first of all, we have to find the sum button. And the sum button is either in 2 different places. It depends on which version of the calculator you have. So on my calculator, I have to hit second and then the stat button, because above stat is this word list, and that's where the thing that I want is. And then once I'm in there, I arrow to the right until it says math at the top. And for me, it is number 5. Okay, that is one place. If you don't find it there, some of the newer calculators actually, like the TI-84 Silver and maybe the TI Inspires, they are going to maybe be under stat, or sorry, second. No, actually, you don't hit second at all. Sorry, you just hit the math button, which is different than this math, okay? They're in 2 different spots. So math button is just below alpha, no second. And when you hit that, you just scroll down, and it's usually 0, and it says summation. If you have this feature with the summation under the math menu, you'll actually see this symbol, and you'll put in all this stuff, and it'll just have an X. And you'll get that part in a minute. Okay, if you have just the sum, and I think that's still available, then you have to know what we're trying to sum. So we are summing this sequence. This is a sequence, right? So now I have to get my calculator to say sequence. Well, sequence is, I think this is for everybody in the same menu. You have to hit second stat, just like before. But this time we're going to only go over to where it says ops. And mine also is number 5, sequence. Okay, so you want your home screen. Once you put those in there, you're going to have your home screen is going to say sum, sequence, parentheses. Now you have to know what arguments to put in. So the sum, we're going to take the sum of the sequence. That's not a problem, but we have to tell them what the sequence is. So with your calculator, there's ways to change your mode and stuff, but your calculator doesn't really like K. It thinks K is a number. So we're going to always use X when we're talking about a variable. So the first thing you put here is your explicit form. So we're going to put 2x. Okay, that's just whatever this equation is that you've got going on. Then the next thing, you have to tell it what variable, because your calculator is not that smart. Sometimes it's too smart for us, and sometimes you can do this with more than one letter. So you have to tell it which letter you're talking about, and then you have to tell it the start and the stop. Of course. That would be good to know how far to add up, right? It doesn't know what we're thinking. And you also have to tell it the step. So this is from 1 to 5, and they're natural numbers. It's always going to be a 1 for us, okay? So you have to put all of these things in there. Then when you press enter, it should work. And the answer is 30, okay? So if you add those up for the first 5 terms. If you have any trouble with those buttons on the calculator, you can message me. You can YouTube this. There's tons of videos. Just if you use YouTube, make sure you get the right calculator. Some of them have newer operating systems. Like I looked up TI-84 and it didn't even match mine. So don't get too frustrated, but the buttons should be there under second stat, math and ops, or just press the math button if you want to see if you have this fancy notation. That would be there. One more little joke for the day. If my page will turn, and now that you know what this is, you might be able to read this. Algebra 2. So what does this mean? What number is this? I bet you can read it. Have a great day, guys.